Okay, thank you. Thank you. So this is not an engineering class. You can all come to the front seats. I'm not going to ask you questions, anything. You can come down, right? So all these front rows are empty. I think all the three stacks are empty, right? So I think, would you like to come forward or you are comfortable there? Comfortable there? Okay, cool. Reminds me of my engineering days. Okay, great. So we'll get started. So I think thank you for the introduction, and I'd like to thank Analytics India Magazine and the organizers for creating such a wonderful platform, right? So the topic is here: enhancing taxpayer risk prediction through large language models. Okay, so maybe I'll just come to the dice, but will they able to see the screen?
I think it's visible.
It's visible, right?
Yeah, yeah.
Okay, wonderful. Okay, so so this is a paper which I co-authored with Kalpita Roy. So we both have been contributing to it. I was primarily taking care from the large language model side, and she was taking care from the data engineering side. Okay, so we'll get started. So about me, I'm a researcher in large language models and generative AI. And very recently, one of my research in large language models have been awarded as a highly commendable research by DKLIM Bangalore. And I also work as a consulting senior data scientist for government of Andhra Pradesh. I have also built two startups. First one got acquired in 2011, and the second one I have done a secondary exit in 2021. Uh, Currently, I also do a lot of advisory mentorship for startups for a couple of venture funds. Okay, now let's get into the topic, right? So tax frauds. I'm talking about, we are doing it in a wonderful day because I think the budget is also going to be, I mean, the budget is also going to be put forward in the parliament today. And here, when you are talking about tax frauds, I'm talking about commercial tax frauds, as in like GST frauds. Okay, it's a real pain point, right? It's not in silos or pockets. It's across the country. It's happening. Okay, and the last part is that whenever there is a tax fraud, is the exchequer which is losing a lot of money. And in the 39th GST Council meeting, right, Nandan Nilekani, he said that by 2020, India has lost almost 20,000 crore in because of the GST frauds. Now, anyone aware when GST came into as an act, it came in? Anyone aware about which year it came in? 2017 it came in. So within 3 years, India lost 20,000 crore, right? So it is absolutely a very big pain point. And here is a demonstration of it, right? So if you think any state is uh, primarily immune of it, definitely not. You can see examples from the extreme north, J&K, Ladakh. You can see it in the east, Assam. You can see it in Bengal. You can see in the west, Gujarat. And you can see happening in the southern belt also. Andhra, of course, that's why I have a job with Andhra, and Karnataka as well in Chennai. So it's everywhere. It's a pan-India event, right? And you always have to understand this aspect that fraudsters are really smart people, right? And they know, without knowing the system, they know how to game the system. So when we were given this problem statement, we were asked to basically understand the system and try to find out the best possible way, right? How can we build something in this area? So it took a lot of risk because large language models are not really for this kind of problem statements. But we understand the power of language models because you would really understand that only one thing which is common between the AI and us is now that bridge has been done with these language models because it can understand language, we can understand language, it can understand the nuances of language, and it does so. So there is something which we still cannot explain, which large language model has, and it has been able to primarily achieve this intelligence, right? So we'll dive deeper into this. Uh, Now I'll quickly talk about the challenges. So when I hope you have seen invoices today, which primarily has a CGST or a SGST. If you're a B2C, you would probably see a CGST or IGST invoiced a number on your invoices, right? So that is primarily on whatever amount you are paying that goes to the government, right? But then there are a lot of nuances in this domain, okay? So how many of you have heard about this aspect of state tax, center tax, integrated tax? Have you heard about these three concepts? Wonderful. Then there are more stuffs to it, which is like how many of you heard about reversal frauds, refund frauds? So you can see that it is, unfortunately, there are 5 different pillars of this text, and in all these pillars there are possibilities of frauds, right? And the fraudsters have been using these loopholes primarily to ensure that they are able to extract benefits, which are the wrong benefits, making the exchequer lose. Okay, so there are process restrictions. So how many of you ever tried to get text data? Anybody ever tried to get text data? Did you get it? Somebody said yes. Okay. How did you will not be able to get it unless you are authorized to use it, and you are authorized to use it only when you are within the government or you are an institution which has been working with the government and you are primarily given permission to use the data. And then also this data is so restricted that not everybody would be able to see every part of the data. Even in the government, at the official level, at the hierarchies, everybody is not allowed to see all the data. We were fortunate to get this problem statement because we now had multiple problems to solve. One is the domain nuances. Then we have this process challenges because everybody cannot see every data. And the third part, which is common, I think all of you are mostly from the either on the research side or on the development side. Anybody from the business side, pure business side of AI? Nobody, right? Wonderful. So you already know that whenever we are dealing with any form of problem statements, we primarily have data stored in tabular form when it comes to specifically to financial data, right? So similarly, in taxation world, every data that is stored is into tables. Now there are odd 1500 to 3000 tables. Each have roughly 10 to 20 columns. And every event, probably when there is a collection, when there is a refund, when there is a reversal, every instance is getting stored in these tables. So now we had a tabular data and we are talking about language models. So you can see that we are really distance apart, right? So that's a third problem. The fourth thing that we had here is that we were fighting against the fraudsters who were really, really intelligent, right? How many of you are working in area of fraud? Anybody? One? Anybody there? Nobody. Okay. So I think one person whom I can see. So you'll be able to acknowledge this part that you are fighting against somebody who is really intelligent and who is really way ahead than what we think. Now, if we have systems which are purely traditional if-else loops, right, or traditional linear mathematical, I would say, if you're using linear mathematical formulas to calculate the risk, I'm sure you will not be able to reach the right goal because there are challenges out there. So that's the fourth problem. The fifth problem is that we are still at the nascent stage of federal data governance, right? So that's still happening. It will definitely take some time. So we understand all these challenges are there already. Now we understand the challenges. So now let's get into the research. So we have taken this broad 5 steps. First thing that we have done is that we have done the gap and the boundary analysis. Now you need to understand the system in and out to understand what are the gaps in it, what are the boundaries in it. Now I'm not going to talk about the gaps today because I don't want, because that's very critical. We don't want to talk about that and we don't want to put forward in any public forum. So we'll talk about the next part, which is existing literature. What kind of existing literature is there, right? So we did a deep dive into that. We introduced an, an innovative method. We call it innovative primarily because we have tested it in the machine learning world. We have tested it with the deep learning algorithms like VIME, TabNet, and we have also used the boosting methodologies. We have started with VIME, TabNet, and we use DeepFM. So we tried with the deep learning world, and then we understood that there is a large potential which lies to the language model, so we shifted to the next part of it. So these are the three journeys that we took, and you can see that while existing literature supported us to test those existing methodologies, we understood that those methodologies are also still not enough to primarily catch the frauds. So that's where we came up with the third part, which is primarily the innovative methodology that we have brought, where we have converted the textual data into a tabular profiles. We then did the profiling and took the next step. I'll talk about more in the next slides. We created a benchmark because pan-India, we don't have benchmark for frauds, right? So that's the next thing that we have to do because there is a lot of data, but has anybody created any benchmarks? No. So we had to create that benchmark as well. So if you see fraud, there are three parts to it. There are defaulters who are also called fraudsters. Then there are fraudsters who primarily generate a lot of credits, which leads others to do frauds. And then there are evaders who use these credits primarily to ensure that they get benefited. So there are three different nuances of frauds out there. It's a research paper, so I'm sorry, I might be putting a lot of jargons. So please bear with me. The last part was to validate the effectiveness. Government doesn't take anything unless there is a validation. So we had to take that part also into consideration. Now, if you take the prior work, right, so there is external research is very limited because when I asked how many of you have access to text data, I saw very few hands, right? Or I saw, I think, only one or two hands. So there is a big limitation of text data, as in like when you are talking about GST, right? So the next part is risk categorization. What we really understood is that there's a lot of risk work which has happened in the credit, in the GRC. So we ensured that we have learnings from there. There we realized that a lot of work is happening in the ensembling and the neural net side. So there are references. If you have the research paper, you'll see those references. You can go and dive deeper into that. Last part was that we did some experiments to see that use credit frauds for language models, and we saw certain benefits. So I'm giving a separate talk in France World AI Festival on credit frauds. So that was the prior learning that helped us to crack this case. So our proposal, I think this is very simple. We said that AI has to be used for fiscal governance. It has to be a natural language system. That was one of the key criteria because tax people are not data scientists, right? You cannot throw them data and say, okay, from this data, try to decide who is a fraud, right? So it has to be interactive system. So there has to be some form of natural language imbibed into that. The next part is primarily the focus on profile categorization. So that's where we put a lot of effort, and I'll show you the math behind it. And we banked on the language model superpower. So these were the 4 things that we utilized, okay? So what we did were these 5 steps: craft a succinct taxpayer profile, considering the finer taxpayer details. Then we generated these profiles. Again, it is not manually possible to generate the taxpayer profile. So we utilized a large language model itself to generate the profiles. Then these profiles were further fed and we tuned the large language model. Then we ensured that the last part, right, which where you have these tokens which are coming out, we removed that part and we added a complete classifier. So that's how we tweaked the large language models to basically reach to our goal. Okay, so we had to ensure a lot of data security. So we had a couple of data experts part of that. So we ensured that the data is very well secured. So we had a lot of maskings done on the data. Okay, so the most important slide, right? This is the math behind that. Okay, So now the first part, right? So you have good time to basically describe this. So I hope there is this thing. Okay. Okay. Okay, leave it. So let's say the first part of it, right? So first thing, what we have done here is that we are considering S. S is basically your structured data, right? So whatever data you have is your tabular data, correct? So we have taken the structured data and we ensured that there are three parts to this. Number one is Z. What is Z? Z is essentially a two-dimensional matrix. Okay, so this is a matrix of the data that you have, which has two columns, A and C, right? So what is A? A are primarily your profiles, your instances. Profiles are still not created, your instances first, right? And then C primarily are your descriptors, right? So essentially your attributes which define these specific instances. Then we ensure that once we have this particular format ready for us, we started doing the profile construction. So profile construction, what we have done over here is that we have ensured that we build a predefined format to create these profiles, right? And what we used here is that we used a feature and a value mapping. So you can see that you have a set notation over here, right? Which primarily talks about the attribute and the instance, okay? Then you have the third part to it, which is primarily your profile tuning part, right? So this is where the LLM comes into picture. The second part of the LLM, right? Where you're using the LLM primarily to tune it and get to our results. So in this, what we are doing here is that if you are seeing this part, this is primarily where we have taken a base pre-trained model. So we know that pre-trained model have their nuances, right? So they have all their challenges, which essentially it has got hallucination. It would probably not do our task. So we ensure that this is where we use two methodologies, right? So one is your last layer tuning, one is your full fine tuning, right? We did not use RAGs and allied because we were working on a data which did not be as like refined to have anything updated, right? So that's where we went with these two methodologies. So you can see here we use a transformation function. So here S is primarily your tokens which you get from your input sequences of your profile, right? And then we converted it into a two-dimensional matrix where you have F. So F is primarily hidden state dimensions. So essentially I say to you that I have removed the last layer, right? And I have taken this hidden states. So that's where I have taken this F, which is the hidden state definition, okay? The next part is primarily your M, where what we have done over here is that we have created a collection of profiles, right? So using this transformation that we have done over here, we have created a collection of profiles. Now in this collection of profiles, what you can see over here is that we have ensured that we are primarily putting your hidden states, and they are also having the tokens of the input sequence, right? So we ensure that we are able to compact and put them together. The last part is primarily your D, which is a compact classifier. And here we have this transformation function. What we are trying to do here is that we have taken this S cross F. S is your input sequence, primarily your tokens count from your input sequence, along with the hidden state dimensions. And we have just converted into F cross G. F is primarily your hidden state dimensions. And G is where you have transformed it into two states, your 0, which is not a fraud, and your 1, which is a fraud. So that's how the whole transformations happen. I'm sorry, a lot of math is going in. I know it's a little heavy for everyone. Finally, this is the output, and we have done this hidden state average. So if you are aware of masked models we are aware of, and causal models we are aware of. Okay, so there's a little bit of difference between masked model and causal models, right? So in case of masked models, we used a methodology where we have done the average. And in case of causal models, we have taken the last token as our outcome. So that's how primarily we have ensured that from step A to step 5, we are able to take the journey from tabular structure to primarily your outcomes as fraud and not fraud. And here you can see, right, how a schematic would look like, right? So this is your tabular data. In the tabular data, we are converting this all done using natural language way by using large language models. We've created a profile out of it. Then these are the number of steps that we have taken, and this is how we are able to define whether it's a risky or a not risky one. And thereby we have given a bunch of taxpayers to the department to run behind, right? To ensure that for the exchequer there is no loss. Okay, so with this, right, this is the methodology which I've already spoken about. Only thing that you need to take care here is that the proportion of data. We all know, anybody who is from the fraud world, I think on one hand, fraud modeling and other modelings have a difference. Fraud cases are too less compared to the actual good cases, right? So you need to ensure that you're able to balance it out. So that's something we have done over here, right? So experimental setup, we used the NVIDIA A40, and then we ensured that we are using basically, so we used, these are two slides which are covering over here. So what we have used the hardware, which is primarily NVIDIA A40, and we have used primarily, and we, so we have ensured that we are using an NVIDIA A40, and we are using the Ampere architecture, and we are using a B16 model, and we have ensured that we are able to use this existing methodologies in area of fraud that has been utilized over here. You can see, and we are able to see that these guys, which are primarily machine learning models, right, they have tanked at a level, right? So you can see the F1 scores. So I think anyone who is not aware of the F1 scores, I think all of you are aware of the F1 scores, right? So if you see the F1 scores over here, that's how we have tried to benchmark them. So if you see over here, we have seen that the machine learning models have tanked somewhere, right? The deep learning models were unfortunately, after a lot of parameter tuning in them, basically hyperparameter tuning in them, we are not able to even reach a very good mark, right? Finally, when we talk about the language models, right, we were able to see that FLAN T5 with a tune all, we're able to reach around 49 as a F1, right? We are trying to both ensure that your false positives and your false negatives both are balanced out. We don't want taxpayers to be harassed, and yet we don't want a lot of frauds to be left free. So that's why we have to balance this out. And you can see over here that Llama, we saw that we did only the last layer, right? We did not do a full fine tuning, which probably is also called the gold standard, but we were able to see very promising results. So I think with this, right, probably I would try to conclude it over here. I am already running out of time, but there are a lot more details. I hope you have read the research paper. If you have not, then there are more details to it, and you can read through it in detail. We had just 20 minutes, so this is what I could present to you, okay? These are the references, so our 40 odd references. You can go through those and you'll be able to see more details of how we have achieved this, okay? Thank you. One good thing happened here is that we actually ran a live testing very recently. This was post I put across the paper. So we have chosen 19 taxpayers, and we did a field testing of this. And you'll be, I would say you'll be thrilled to know that 18 of them, out of them, were actually frauds, which is a normal methodology. By normal methodology, we were never been able to find them out. And they're some of the big players. So with this, I'd like to conclude. Thank you so much. You can reach out to me there. And